Solving rational equations. Now that we have the basic operations figured out, how to multiply, how to divide, add, and subtract, what we can start doing now is using those techniques to solve equations. Before I begin doing any of the work here, I want to let you know there are plenty of methods that you can use to solve rational equations. What I'm going to do here is highlight two of the different techniques. The first is going to be using cross products. Okay, so for example 1, what we have is a proportion. It's a rational equation because you have x's in the denominators, but you can look at this as a proportion. It's two fractions set equal to each other. And a technique that you can use for solving any proportion would be cross products. Okay, so that's what we're going to apply here. All right, to do that, we basically just multiply our diagonals. Okay, so if I were to multiply the 3 to this binomial, I would just have to make sure that I distribute the 3 to both of the terms. That would give me 12x plus 15. The other diagonal product, which would be the x plus 1 and the 9, we're going to multiply those together as well. We're going to get 9x plus 9. And the thing about cross products is that they're equal to each other. When we take those diagonal products, they will be equal. Okay, so now what I've really done is I've changed a rational equation into a linear equation. We'll go ahead and subtract the 9x. We get 3x plus 15 is equal to 9. All right, and generally the next step here would be to subtract the 15 over to that side. But just for the sake of showing you something a little bit different, I want to make the observation that everything here is divisible by 3. So if you want to, you can just reduce the whole problem by a factor of 3. We would get x plus 5 is equal to 3. And then instead of subtracting the 15 and dividing by 3 at the end, I can just subtract the 5, get x is equal to -2. All right, but for every problem that we do, there is a caution. Okay, you need to make sure that the answer that we produce, the -2 here, you need to make sure that the answer that you produce does not make the original rational equation undefined. Okay, rational equations, because we have x's in the denominator, there are certain values that are not part of the domain here. For example, -1. You can't have -1 as a solution because it would make this undefined. -1 is not part of the domain. Likewise, -5/4 would not be an answer either. So ours, -2, is good. You can plug that in and you can see that the left and the right will be the same thing. All right, for example 2, we do not have a proportion. Okay, so we're not going to use cross products. However, I do want to make the point here that you can easily add these two fractions together, make a single fraction, which would then allow you to do cross products. That is an option. But what I'm going to do here is highlight a different technique, which is to find a common denominator. Okay, so if I look at all the denominators that we have here, we got a total of 3 of them. 2 of them are the same, x and x. Okay, you don't actually have to have a couple of them the same. We just happen to have 2 that are the same. The other denominator is a 5. Okay, so what we really have here are 2 unique factors. You have an x and you have a 5. Whatever a certain fraction is missing, just make sure that you multiply the top and bottom of that by the factor that would be missing. All right, so what we're going to do is take the 3 over x and multiply the top and bottom by 5, because that would be the factor in the denominator that this one doesn't have. Okay, so we've got 3 times 5 over x times 5. The second fraction does have the 5 as the denominator. What it doesn't have is an x. So we're going to multiply the top and bottom by x. The third fraction does have an x for the denominator, but it doesn't have a 5. All right, and what's really neat here is that by creating a common denominator, you don't really need to pay attention to the denominator anymore. So the only part that we really need to pay attention to here will be the numerators and the operations. We've got 3 times 5, which is 15. You've got 8 times x, which is 8x. We're going to set that equal to a -13 times 5, which is 65. And you don't have to pay attention to the denominator at all. It doesn't make any difference. Okay, so working with this equation, we'll go ahead and move the 15 over by subtracting it. So you're going to get 8x is equal to negative 80, which means that x is going to be negative 10. And as long as that answer does not make the original equation undefined in any of the fractions, then it's a good answer. The only value of x that we're not allowed to have as an answer is going to be 0 itself. That would be the only answer you couldn't take. So this is good. Example 3 is a lot like example 2. What we have on the left is some addition or subtraction. In this case, it's subtraction. Okay, you've got 1 minus this rational expression, and we have it set equal to another rational expression. Okay, now if you want to, you can manipulate this so that you get that proportion. You can then do cross products. But what I'm going to do is keep with the theme of getting a common denominator. All right, so the 1, I'm going to think of that as a fraction, 1 over 1. Okay, so it has a denominator of a 1, which really doesn't do anything, but it's more of just a filler, and you know that it's there. The other two are going to have unique factors. You've got x minus 5. You also have just x. So we're going to need to make sure that every fraction has an x minus 5 and an x in the denominator. All right, so for the first fraction, we've got 1 over 1. Okay, it's going to need to receive top and bottom an x and an x minus 5. The second fraction, we've already got the x minus 5. So that just needs to get an x. The third, we've got 3 over x, so it needs to get the x minus 5. All right, now remember, we set this up so we have a common denominator. For the rest of the problem, that doesn't really matter. We just focus our attention on the numerators and the operations. Okay, so we're going to multiply this together. We're going to get x squared minus 5x. We're going to have some subtraction. That'll be 8x is equal to some distribution. We get 3x minus 15. Okay, now what type of an equation do we have this time? We actually have a quadratic. We have a quadratic equation. So we're going to move everything to one side. Okay, let's see if we can do this all at one time. These are going to group as negative 13x. We also have a 3x here that will move over through subtraction. So we're going to get negative 16x. The constant is going to be plus 15. And we set it equal to 0. All right, so what factors to work here? What multiplies to give us 15, but will add up to give us negative 16? And that would be x minus 15 and x minus 1. Their product will be positive 15, but they add together to give us negative 16. So the solutions will be 15 and 1, as long as they work for the original equation, which they do. Only thing that would be off the table would be a 0 and a 5. So both of those are answers. All right, let's do one more problem. And for this, we're going to need to start with factoring. Okay, not the numerators, but the denominators. This middle expression that we have here, the bottom is in standard form. But if we factor it, and I hope you recognize that's the difference of squares, if you factor it, you're going to get x plus 3 and an x minus 3, which happen to be the denominators that we have in the other two. Okay, so the first fraction is going to need to get an x plus 3. The last fraction is going to need an x minus 3. All right, so let's go ahead and write all this up without denominators. The top here is going to be 6x plus 18. That'll be equal to, nothing changes here because that denominator was complete. We get 8x squared minus, okay, and here we want to be careful. This is going to distribute in. We can think of distributing a negative 4x into this. So we're going to get negative 4x squared you're also going to get a positive 12x. Okay, negative 4x times negative 3, positive 12x. And again here, we have a quadratic. Okay, so let's group everything together. These will group to give you 4x squared. We've got the 12x, but we're going to subtract this over. So we get 6x. The 18 becomes negative 18. We set things equal to 0. Okay, it looks like we have a factoring by parts problem. However, before we do that, notice that all of these are even numbers. So we can actually divide a 2 out. We get 2x squared plus 3x minus 9. And even 0 divided by 2 just comes back as 0. So we're dividing everything by 2. It'll just end up giving you some smaller numbers. Okay, factoring by parts. What multiplies to give us negative 18 and adds to give us a 3? That would be positive 6 and negative 3. Okay, their product is going to be the negative 18, but they group to give you a positive 3. All right, so factoring by parts. We'll separate those. We can factor out a 2x. We get x plus 3. So this also has to be x plus 3. We get that by factoring out a negative 3. All right, so completely factored, it's going to look like this. You get 2x minus 3 times x plus 3. So the solutions we get from this would be a positive 3/2. We would also get a negative 3. Those would be our two answers. But like all the other problems, what we want to do is look at the original equation and figure out what we're not allowed to use. Okay, here you can't have a 3. 3 minus 3 is 0. So it can't be a 3. We got negative 3, so that's different. However, here you can't have a negative 3 because that makes this 0, which would also make this 0 because that's one of the factors as well. So this is what we call an extraneous solution. It's an extra solution you get because of the approach that we took at this. However, this is not an extraneous solution. That is the one and only solution to this problem.
Wait, what?